Yeah. All right. So module 4, statistics. We're going to go through it. I'm going to give you a crash course on data collection, experimental design. We're going to get what I would normally do in 2 weeks in an AP Stat class done in 30 minutes. Right? So observational study. An observational study, you just kind of observe what's going on, right? You could give people a test and see how they do on a test, those sorts of things. A survey is a form of an observational study. You could have people just perform a task and see what happens, how they do with the task, and so forth with an observational study. All right. So if you wanted to see how exercise, or let's see, if you wanted to know what the resting heart rate is of the average student at Cleveland High School, you would just observe by looking at their beats per minute, their heart, right? You won't do anything but just take some measurements, okay? So that's an observational study. An experiment, you guys probably learned all of this stuff in your science class, right? On an experiment, you impose a treatment on some experimental units or subjects. So for that same thing, if I say with the heart rate, right? I would like to know if the heart rate is increased by a certain activity, right? So I would have the students not do the activity, take their heart rate, and I would have another group of students do the activity, take their heart rate. I could actually do it with the same group of students too, right? But the treatment that I would pose would be the activity. The subjects would be the students. And I would have a control group, right, which would be the students that did not do the activity. In the case of a medical study, if I'm trying to test medicine, you always have to test using a placebo, which is something that looks like the medicine, is administered in the same way as the medicine, but has no medicine, right? I'm sure you guys are all familiar with these terms. You should be from your science classes. All right. Simulation. All right, so with the simulation, a lot of times when you're gathering data, you want to know if whatever phenomena you were looking at, you want to know whether or not it would happen by chance or not. So with AP statistics, the very first thing that I have them do for the year is I give them 3 cups of water, labeled A, B, and C. 2 of the cups of water have tap water, and 1 has filtered water. I want them to taste it to see if they can tell the difference between the flavor of tap water or filtered water. So I have them taste it, mark down their answer, and then we see how many people got the right water, right? So, for example, in this case, I think that like 15 out of 20 were able to guess. And what you want to know is could that have happened by chance or not? And the way that you would do that is you would do a random simulation. So the way that I carry out a random simulation is if I had, let's say the proportion was 15 out of 20 that got it right? Well, if I was going to see if that happened by chance, what I would do was I would choose randomly. So let's say I would choose 20 numbers randomly. Numbers, and let's make them 1 through 3 randomly. And I would make those my correct guesses. And then I would see how often that happens. So if I was to do that, I could use my calculator. And it turns out that in my math function, I have a random number generator. And it's right here, it's rand int. So what this does is it's going to choose integers 1 through 3, and it's going to choose 20 of them. All right? What this is going to simulate is correct guesses, right? So, for the first person, the way it looks is, the first person chose the first cup, right? The second person chose the third cup, and so on. Now we're going to do this random generator again, and we're going to see if they chose correctly, right? So I can do, go up here and do the rand int again. And this is the way you would do it. So it looks like person 1 didn't get it, right? Person 2, no, that's a correct guess. You see what I mean? This is a correct guess. That's a correct guess. That's a correct guess. This is not. And then I can scroll through. So that's how you make a simulation. Oh, 3 is. So 3 was correct. And so on. But this is how you would randomly simulate that. You know what I mean? You have 3 possible chances. You take one as being the correct guess. And then you try to say, hey, if I just randomly made some numbers, what are the chances that you would actually get it right? And it turns out it makes sense, right? It should be about 1 in 3, right? You should be able to guess correctly and about 1 out of 3 times. You know what I'm saying? Yeah. So that's an example of a simulation. All right. Okay. A survey is another way to get data. You guys know what a survey is. We don't need to get crazy about that, right? All right. So let's see. Weird. Okay, there we go. I'll move these things around a little bit. Oh, they're in the wrong spot. Okay, so how would you collect data? Obviously, you're going to figure out the effect of exercise on relieving depression. You would have to have some depressed people, first of all. Don't raise your hand. Just keep it inside. Okay, that's probably not a good way to collect depression. But anyhow. You would have some depressed people. Some of those depressed people you would randomly select to get exercise. And then you would measure their levels of depression. And then other people you would not have exercise, and then you would measure their level of depression, right? So that would be an example where you would want to use an experiment. All right. Now, study of the success of graduates of a large university in finding a job, you would want to use an observational study, right? Because you'll pretty much just pick a group of people that graduated from this university and ask them a question. You might send out a survey, or that information might be something that the university already has, right? I'm not sure. Yeah. A survey? Well, I don't know. Could be an observational study, because a lot of times universities have that information. They actually don't. They would be not doing a very good job if they did not. Okay. All right. So a confounding variable occurs when you're measuring something other than the variable that you want to measure. It's kind of a mouthful, but this is how it looks. Say in this room, I wanted to know how many people love Taylor Swift, and immediately make raise the hand. So save that for posterity. Yes?
Yeah.
You? All right. All right.
Hey.
Old Taylor, or new Taylor? Old Taylor, for example. Okay. Anyhow, so
I think she's the best.
if I had, it might be the case that females like Taylor Swift more than males in general, right? So if I had, it might not be true. I'm just hypothetically, okay? if that were true, and I had a group of students that were predominantly female, and I asked them that question, it might be the case that more of them are saying yes than are saying no. I might be getting more, yeah, I love Taylor Swift, than no, I don't like Taylor Swift. And then I'm not measuring whether students like Taylor Swift, I'm actually measuring whether girls like it.
Not sexist.
Just everything that I said aside that. So that would be the example of a confounding variable. Okay? Yeah? Alright. Blinding is a technique where you use your thumb and you gouge. Oh wait, sorry. Talking about something different. No.
Can we try it?
No. In blind, when you're blinding, what you're doing is you're making sure that the people that you're giving the experiment to don't know that they're getting, whether they're getting the experiment or the treatment. It's always the way it has to be. You always want to have a blind experiment, right?
Yeah.
Okay? Double blinding is when you use both thumbs. No, no, double blinding is where both the experimenter and the person being experimented on don't know whether they're in the experiment or the control group. So they do that in terms when they're testing medicine, right? They don't want the doctor to give the people getting medicine more favor because they want a good result. So they make sure that both the doctors and the people receiving the medicine don't know whether they're actually getting the medicine or getting the placebo. Right? So that is a double blind experiment. If you were taking notes, there it is for you on video land. Okay. Randomization is a process of randomly assigning subjects to different treatment groups, and that's always the way that it has to be. You always have to randomly assign people to different treatment groups. So if I was going to experiment on you all, what I would do is I would give you, I don't know, there's roughly 20 of you here. I would randomly assign you numbers 1 through 20, or I would just go through and count 1 through 20, right? And then I would use a random number generator, like I showed you before, and I would get numbers 1 through 10. Randomly, or sorry, 1 through 20, I would get 10 of those numbers, randomly generated. And if your number came up, right, you would get put experiment group, and the remaining people would be in control group. You could do it with numbers in a hat. I could put numbers 1 through 20 in a hat, little pieces of paper, and assign you numbers 1 through 20, and then pick 10 numbers out of the hat. If your number comes out of the hat, then you get experiment in the experiment. Okay? Does that make sense? That is randomization. Okay. Replication is just doing the experiment over and over and over and over and over again. What is the purpose of doing that? The purpose of replication is to avoid any other variables other than the variable I'm trying to test to come into play, right? So it might be the case, so say I want to see how people perform on a test while they're chewing gum, right? Some of the people that I am experimenting on may just be having a really crappy day, right? If I experiment on a lot of people, the chances are I'll have less people in that group that are having a crappy day and would have done bad on a test whether they're chewing gum or not, right? So that's why you use replication, to eliminate the effect of outside variables or confounding variables on your actual experiment, right? We're going to look at some sampling techniques. One sampling technique that really sucks is a convenience sample. It sucks a lot because you don't get a representative population. So when you are sampling, you want to make sure that you get a representative population. So say I wanted to know something about people at Cleveland High School. Let's go with, do you like Taylor Swift? Okay. If I was to go for a convenience sample, so say I was like, okay, I need to get this data. I'm standing out in front of the gym. I'm just going to ask people as they come in the gym, do you like Taylor Swift?
I do that.
I don't know. I might not make friends that way. But anyhow,
It's a
the problem with that is that I don't really care. I'm just grabbing whoever comes along, right? I might actually wind up asking all seniors. If for some reason, or actually it'd be more likely that I would ask all freshmen, right? Because they're going into gym class, right? They're going into PE, right? And I'm not getting a representative sample. I want to know about all the kids at Cleveland High School. What I'm wind up getting is a bunch of freshmen answers, right? And they're confused anyways. So, anyhow, sorry, freshmen. Anyhow, so that's why a convenient sample is not good. You want to be systematic. You want to actually have a plan that leads you to getting a representative sample, a sample that represents the population you want information about. So one way that you might do that is stratify your sample. So again, with Taylor Swift.
Do you like Taylor Swift?
I neither like nor dislike her. There's some things that I think I do really like about her. That song,
Say it. We're going on.
the one version of the song.
Say it.
So imagine in this class, I wanted to know how many people like Taylor Swift, but this class had 15 girls in it and 5 boys, right? It might be the case that if girls like Taylor Swift more than boys, right? If I just ask everybody, I will probably get an overwhelming amount of yeses, maybe more than I would have if I had an even number of boys and girls in the class. So the way that I will remedy that is I'll randomly select 5 girls from the group of 15 to ask the question, and then I will select the 5 boys, and then I'll have an even group, right? So I stratify them by gender. Okay? So that's a stratified sample.
I stratify.
With a cluster sample, I'm going to take a group, and I'm going to take a representative cluster, and I'm going to get some data from them. So the example that I came up with was like this. Imagine at a stadium, say a football stadium, I wanted to ask the question, do you think the prices are fair? And if you look at a football stadium, right, you've got your football field in here, and then right here you've got the good seats, pretty expensive, and then you got the kind of good seats, pretty good seats, and then out here you got the cheap seats, right? So we got cheap, we got pretty good, and we got real good seats, right? Well, I would use a lot of time and resources if I was to ask every person in the stadium, hey, do you think the prices are fair? So instead, what I would do is I would take a cluster of those people that represented the entire population, right? People that pay a lot of money for tickets, people that pay a good amount of money for tickets, and people that get the cheaper tickets, right? So and you know your stadium is broken up, right, in sections, like that, right? So if I was to just sample this section and everybody in this section, I would get a little cluster, right, of the entire population that represents all the different ticket prices. So that's an example of a cluster sample. Yeah? All right. Systematic sampling is just what we've been doing, okay? Where we actually randomly select it. So I've already talked about how to do this, right? It's what I talked about when we will go through the process of randomly selecting someone to be in our experiment group, or randomly selecting groups of people that we will get data from. All right? Okay, let's try it ourselves. You select a class at random and question each student in the class. What type of sample is that?
Good.
This is one we just spoke about, which is cluster sample. It's a cluster sample, especially if that class, if I wanted to know information about everyone at Cleveland, if that class had a good mixture of freshmen, sophomores, juniors, and seniors in it, that would be a great representative cluster to use to represent the entire population at Cleveland High School.
That was really test my brain.
Hey, you assign each student a number, and after choosing a starting number, question every 25th student.
I'm playing Judith. She's like 800.
That would be a random sample. I think this one is gonna go with the systematic sampling. But it is an example of a random sample. All right, that's a little more clear. Okay, hey, if you guys want to try some of these, you can try them. They are they'll be on the website if you want to check it out. And that's it for experimental design. Thanks, guys.
Oh, anyway.